wooden ball has a mass of 60 kilograms and a volume of zero point 0.1 meters cubed. So we have some questions here. And first, we're going to determine the weight of the ball. So weight equals mg. So mass is 60 kilograms, and for gravity, we're going to use 10 meters per second squared. And so we're going to get 600 newtons for our weight. And now determine the density of the ball. So density equals mass over volume. And so it's going to be 60 kilograms over 0.1 meters cubed. And I think that should be 600 kilograms per meter cubed. Now we're going to put this ball in a tank of water, and we're going to hold it completely under the surface. And we want to determine the buoyant force on the wooden ball. So there's going to be two forces. One's going to be going up, and that'll be the buoyant force. And one's going to be going down, and that'll be the weight. And now we want to determine this buoyant force, which we remember the buoyant force is going to be equal to the weight of the fluid displaced by the object. So a good useful way to write this is right here, rho f times vf times g. And so the rho is the density, and we can recall or look up that the density of water is 1,000 kilograms per meter cubed. And the volume we're displacing, because we know we're completely below the surface, we know we're displacing 0.1 meters cubed. And gravity, well, again, we'll use 10 meters per second squared. So this should give us 1,000 newtons for our buoyant force. Alright, so now we let go of the ball, and we want to know what it is going to do. So to know which way it's going to accelerate, we can check out the net force, and that'll tell us which way our acceleration is. So F net is going to equal the buoyant force minus the weight force, and we can look, and those are the only two forces we have in the y direction. So our buoyant force is going to be 1,000 newtons, and that's going up. And so we're going to subtract our weight, which would be 600 newtons. And then we can see that that'll give us a net force of 400 newtons, and it's positive, so it should accelerate up. And because we have positive F net. So after it eventually comes to rest, what volume of water is displaced by the ball? So at rest, we know that F net will be 0. And so we know it's going to be floating in some way. And we know that our weight force is not going to change at all. It's going to still be 600. So we want this to equal 0, and this is still 600. So we know that we need a buoyant force of 600 newtons. And so let's solve for 600 newtons using our equation here. So rho f is going to be the same. Now the volume displaced is going to be different, and gravity is of course going to be the same. So it looks like we'll have 600 newtons divided by 1,000 kilogram meter cubed kilograms per meter cubed times 10 meters per second squared. And if we just punch that out, I believe we get a volume of 0.06 meters cubed displaced.